So let's do our first derivative test. For our first derivative test, we get f prime equal to 2x minus 4. All we did was take the derivative of these terms, and this is what we got. And then what we need to do is set it equal to 0 and solve. When I add 4 to both sides, I get 2x equals 4, and I get x equals 2. Alright, so we only have one critical point for this curve that we're trying to graph, and it's at 2. So in order to find out what our first sign is for our double sign curve sketching strategy that we got here, is we first need to pick a number that's in this interval. I'm going to pick 0, and then I take that number and I plug it into f prime. Once I plug it into f prime, I see that I get 2 times 0, and then I have to subtract 4, which equals negative 4. So I have a negative number before 2, a negative slope before 2, which tells me that the curve is decreasing before 2. Next, I'm going to pick a number that's after the 2, and then plug it into my f prime. I'm going to pick 3 for that one. It doesn't matter which one you pick. I have 2 times 3 minus the 4. I get 6 minus 4, which is positive 2, so I get a positive number right there. Cool. So now I know where this curve is increasing and where it is decreasing. Next, I'm going to do my second derivative test. So I do my second derivative. Let's see. That means I got to take the derivative of that. I'm going to get 2x. Actually, no, just 2. Now, if I try to set this one equal to 0, it doesn't make sense. 2 does not equal 0. Because this is a constant function, we don't even need a sine line graph because everywhere it's going to be positive. So, when we go to graph now, what I'm going to do is first, draw my x and y axis, and then at that's a pretty bad x and y axis. At 2, I'm going to draw my critical point. And then for our second derivative test, I don't have any dotted lines to draw. So what is our curve going to look like? Well, before that, this line right here, we have a minus, and then the second sign would be positive because it's positive everywhere. So we have minus, positive. And then right after it, we have a positive, positive. And we know that the minus positive would be decreasing but concave up, and then the positive, positive would be increasing and concave up. So our graph would look something like this. Now, that's just a rough sketch. And I didn't start at any point. So my sketch isn't as accurate as it could be. So what you normally want to do is you want to have at least one point. Then you can do another sketch from that point. It would make your graph a little more exact. I like using the y-intercept if possible. So I plug 0 into these x's up here so I can get a y-intercept. And my y-intercept happens to be 3. So I put a dot right there, and then I do this kind of thing, and I got my rough sketch. Another point that might be simple to find would be this one right here. In order to get that one, we would just need to plug the 2 into this, and we would get 4 there, 8 right there, so that would be negative 4. I'm sorry, yeah, negative 4. And then add 3, we get a negative 1. There's the work right there if you want it. So that actually will make my curve look something more like, let's see, coming from that point, let's see, I got to put a point right there. It'd be down, concaving up, and back up. And because we have symmetry about this line right here, I know that this point over here should match that point. Alright, so that curve right there is pretty good. And because it was easy for me to find 2 points, I did, and I'm done with that one. Alright, next we're going to do this guy.